Hello everyone, welcome to a brief web presentation that is designed to enable you to understand the game theory in Fritz Scharpf's article that we're reading for week 7. One thing I should note is that I've marked in the reading questions for Scharpf, which I will put up shortly, when you should watch this presentation, and I'm not going to try to talk about any of the economics in Scharpf. I'm just going to try to help you understand the way he uses game theory. Game theory can be an intimidating phrase. It sounds like it's something really complicated, but especially in the form that we're going to be using it and that Scharpf is going to be using it, it's actually quite straightforward. The main barrier to understanding what's going on is some jargon that makes it seem more complicated than it really is. So if you wanted to speak formally, you could say game theory is a systematic approach to understanding the outcomes of strategic interaction. Well, what is strategic interaction? It's just interaction between two or more people in which the best choice for each depends on what the other or others decide or decides to do. Now, you might say, well, what would be an example of that? Here's a really, really simple one that you've played lots of times, right? If you're trying to get through this game, trying to prevent me from winning, I'm the crosses and you're the knots. If I play the cross there, you're going to play here. Why? Because if you don't do that, if you play here, say, then I am going to play here, forcing you to block me, at which point I play here, and then you're stuck, because if you play up here, I play over here. Or, I bet you've played this before, right? If you play over here, I play up here, and either way I win. So what makes sense for you to play all the way back as soon as I have played my cross in the middle of the board is for you to play in the corner, etc., etc. That's all the strategic interaction is. It's based on what I think the other player or players are going to do, what is best for me to do. That kind of situation where I have to think about what other people are going to do, that's strategic interaction. The most famous example of this, and those of you that are taking GV441, the Introduction to Comparative Politics, will have encountered this, and many of you have probably encountered in various contexts, is the so-called prisoner's dilemma. And in the prisoner's dilemma, we imagine two prisoners, whom I've called here Mr. Rowe and Miss Column. Two prisoners who committed a crime together, and they've been put into separate cells by investigators and told that they have two choices. They can keep quiet or they can implicate their partner. If they both keep quiet, and sometimes that's known as cooperating, we'll call that cooperating. If they both keep quiet, they both get 2 years in jail. There's some evidence for them for their crime, but if they both keep quiet, they both get 2 years in jail. On the other hand, if they can be convicted of a more serious crime, they would get 4 years in jail. 4 years in jail. And the prosecutors or the investigators in this scenario have offered both Mr. Rowe and Ms. Column a deal. And what they say is that if you implicate your partner, give us more evidence, we'll only give you 1 year in jail, but they'll get 4 years in jail. And they offer exactly the same deal to Ms. Column. If she implicates her partner, she only gets 1 year in jail, but if he implicates her and she doesn't implicate him, she gets 4 years in jail. The final possibility that the investigators say is that if you both implicate each other, then we'll give you some credit for having confessed, but we'll have enough evidence to put each of you in jail for 3 years. So by saying you're going to go to jail for 1, 2, 3, or 4 years. I've also set these up as the rank of the outcome, right? The best outcome is just 1 year. So we can call this the most preferred, the first most preferred, and so on. Okay, so that's the prisoner's dilemma. They have to decide whether they're going to cooperate or defect, or they're going to keep quiet or implicate their partner. So what should they do? Well, let's suppose that Mr. Rowe is very systematic about it, and he thinks Ms. Collum has two choices. Either she's going to keep quiet or she's going to implicate me. What should I do in each of these circumstances? Well, suppose she keeps quiet. If she keeps quiet, then I'm facing a choice between cell number 1 and cell number 3. In cell number 3, I get 1 year in jail. In cell number 1, I get 2 years in jail. I think I will take this choice, right? So if Mrs. Collum is going to keep quiet, I should implicate her. I should defect. All right, so now I know what to do if I think Ms. Collum is going to keep quiet. Well, what if I think she's not going to keep quiet, if she's going to implicate me, if she's going to defect? Now I'm facing a choice between cell 2 and cell 4. In cell 2, I get 4 years in jail. In cell 4, I just get 3 years in jail. I'm going to pick that one, right? So now what we've discovered is that if Ms. Collum will cooperate, Mr. Rowe should defect because 1 year is better than 2 years. If Ms. Collum will defect, Mr. Rowe should also defect because 3 years is better than 4 years. And Mr. Rowe should always defect, and because Ms. Collum's choices are exactly analogous, she should always defect too. Formally, in the fancy terminology of this, defect is a dominant strategy. It's best in all circumstances, no matter what the other player does. It can also give this the outcome that you get then, which is cell 4, the fancy name of a Nash equilibrium. Each player has picked the best strategy, assuming the opponent plays the best strategy. Another way of putting it is that Mr. Rowe can't improve his outcome by changing his choice, and neither can Ms. Collum. People sometimes find this a pretty depressing outcome because, in fact, Mr. Rowe and Ms. Collum would be much happier if they both got 2 years in jail. They wind up both with 3 years in jail, but they could have had just 2 years in jail if they had both kept quiet. So the fact that they can't cooperate means that they both wind up spending more time in jail. All right, now let's look at another game, which is called the chicken game. And chicken is used in the slang sense of coward. So in a chicken game, for instance, 2 cars race directly at one another on a road, and whoever swerves aside or turns aside, that's the loser, that's the chicken. The person who doesn't turn aside is the winner. So that's the chicken game, and we can set up this same kind of thing, which technically is known as a payoff matrix, right? Matrix being a fancy name for a table, so it's the payoff matrix with the payoffs, how much the players get or what the players get in the end. And here, the colored numbers are rank order. So this is the most preferred, first, second, third, fourth preferred. Okay, so Mr. Rowe and Ms. Collum are playing this game, and they have the same sets of moves. They each have the same moves. They can keep going, carry on, keep driving straight, or they can turn aside. They can swerve. Those are the two things. If they both carry on, they crash. If they crash, that's the worst outcome for either one of them, right? The fourth place outcome. The best outcome for Ms. Collum is if she keeps going and Mr. Rowe swerves aside. So that's her best outcome because that's the way she wins. He wins if he carries on and she swerves aside, so that's his best outcome. And if they both swerve, well, at least they're alive, They haven't lost the game, but they haven't done as well as they might have either. Okay, so those are the outcomes, and this is whole thing, as I say, is called the payoff matrix. So if you go through the reasoning now, you can see that, just let's look at it from the point of view of Mr. Rowe. Again, he's being systematic. What are Ms. Collins' possibilities? Well, she could carry on. If she carries on, Mr. Rowe should do what? He should swerve. Why? Because his third best choice, the one where he loses, is better than his fourth best choice where he dies. If, on the other hand, she's going to swerve, what should he do? Well, he can either keep going, in which case that's great, he wins, or he can also swerve, and that's not as good, so he should carry on. That means he doesn't have what's called a dominant strategy, because there isn't one thing that he can do, no matter what Ms. Collins does, that's his best move. And it turns out that is written down here. There's no Nash equilibrium. There's no thing that's going to happen if each player plays their best move. So they can't tell what it is. Now suppose, let's change it a little bit and say that two people are playing, but one of them is a nutcase. We'll call it Mr. Rowe. He hates swerving. He so much doesn't want to be the chicken or to show cowardice that he hates that more than he fears dying. So we need to change the preferences. Now the crash is only his third least favorite thing, because turning aside to avoid a crash, he hates that more than even dying. It could be, actually, now that I look at it, it would probably be better to say that this would be his second favorite one, and this would be his third favorite one. Why? Because he hates swerving, and he prefers carrying on in all instances. Doesn't change any of the analysis if you do it that way, but just for consistency. Okay, so Mr. Rowe, we can say, is kind of a nut, because he would rather die than lose the game. How does that change things? Well, let's go through Ms. Collins' reasoning. If she, well, let's go through Mr. Rowe's reasoning. Is she going to carry on? If she's going to carry on, then he should also carry on, because he prefers dying to swerving. If she's going to swerve, he carries on, because he prefers carrying on to swerving. So carry on is a dominant strategy. He prefers winning the game to showing cowardice. So carry on is a dominant strategy for Mr. Rowe. Now we can look at what Ms. Collins will decide to do. She knows that Mr. Rowe is going to carry on no matter what, having gone through that same analysis. So she should swerve. 3 is better than 4. Not crashing is better than dying. This makes box 2 a Nash equilibrium. Neither player can improve their outcome just by switching to something else. You just look at them systematically. All right, I will pretend to be Mr. Rowe. What can Ms. Collins do? Either she can do this or she can do that. Okay, what do I want to do in each of those cases? And you just step through that. It's actually less complicated than tic-tac-toe, right? I mean, tic-tac-toe, you have to think about different moves that the other player should make. This is very straightforward. This kind of game theory is very. So the lesson that one ought to draw from that is that even in a game with exactly the same rules, the available moves and the consequences of these moves, right? So the chicken game doesn't change. You can still either keep going straight, carry on, or you can swerve, and you still get a crash if both players carry on. So those things don't change, but a player's preferences between the outcomes how they value dying versus showing cowardice, those preferences can affect the outcome of the game. All right, we've now done enough to understand the games that Scharpf puts in. And I hope that at this point you can see how you approach these payoff matrices forward. So we can do that with Scharpf's game. As I said, I'm not going to talk about the economics of this. I'm just going to show you how to read the games. And they're set up just like the ones that I have gone through. It doesn't have colors, so I've added a little here to show you that the government preferences, who are like, the government's like Mr. Rowe, right? So his preferences are here. Put them in the blue boxes. And then the unions are like Ms. Cullum, and their preferences are over here, right? And there are two moves for each player. The government can be expansionary, it can do Keynesian fiscal stimulus, it can conceivably do monetary stimulus depending on whether or not it controls the central bank, or it could be restrictive. Unions could be moderate in their wage demands or aggressive. And for reasons that are set out in the text, Scharpf ranks their preferences in this order, that unions most prefer an aggressive wage policy in an environment in which the government is being expansionary. Their second choice would be a moderate wage policy in expanding conditions. Their third choice would be a restrictive wage policy a moderate wage policy in restrictive conditions. Their worst choice would be an aggressive wage policy in restrictive conditions, because by trying to get their wages up in economic circumstances that don't sustain it, they wind up causing greater unemployment. That's discussed in the piece. But for present purposes, all we need to know is that these are the order of preferences, 1, 2, 3, 4, and then he gives the government preferences like that. So we can step through this in exactly the same way. Let's look at it from the point of view of the government. Unions are going to do one of two things. They're going to be moderate or they're going to be aggressive. All right, suppose they're moderate. What does the government choose? Well, it's choosing between its first preference, expansion with moderate wage demands, and its third preference, restrictive with moderate wage demands. It's definitely going to choose to be expansionary. That's its first choice. The first choice is preferred to its third choice. What if the unions are aggressive? Well, then it's choosing between its second choice and its fourth choice. Its second choice is expansion with aggressive wage demands. Its fourth choice is to be restrictive with aggressive wage demands. It's definitely going to pick its second choice. It's better than its fourth choice, so it's going to be expansionary. What that means, then, is that expansionary is a dominant strategy for government. Since government will be expansionary in all cases, unions should be aggressive. One is better than two. Now, this is obviously a very simplified picture of a very complicated situation. You can think about timing and so on. Scharpf is very well aware of how this is a kind of abstraction, but the point he particularly wants to make is that the government won't switch to a restrictive policy if unions have aggressive wage demands, because that would leave them in an even worse situation. This means that a government with this set of preferences, this set of Keynesian preferences, Scharpf calls them, won't be able to threaten unions with anything when unions are raising aggressive wage demands, because the unions will know the government is not going to switch to a restrictive policy. Okay, now let's look at Scharpf's other game, which he calls the monetarist game. And the difference between the Keynesian game and the monetarist game is the preferences of the government. So this is just like the chicken game and the chicken game with a nutcase, right? The moves are exactly the same, but the preferences are different. Here he's changed the preferences of the government to make them care less about unemployment and more about fighting inflation. You'll read more about that in the readings. But the preferences now are most preferred for the government is a restrictive policy with moderate wage demands, followed by an expansionary policy with moderate wage demands, followed by a restrictive policy with aggressive wage demands, and then the very least favorite thing they would be the expansionary policy with aggressive wage demands. So we can go through the reasoning again. Government looks at what unions can do. Unions are either going to be moderate or aggressive. If they're going to be moderate, what is the government choosing between? So here, moderate is choosing between its second most favored option and its first most favored option. It's going to choose the restrictive option because that's its most favored. Alternatively, unions might be aggressive. What is the government choosing between? It's choosing between expansion, which is puts it in its least favorite cell, or restriction, which puts it in its third most favorite cell. So it's choosing between its worst choice and its second to worst choice. It's going to pick that one. So that means that to be restrictive is a dominant strategy for government. It's going to pick it if the unions are moderate. It's going to pick it if the unions are aggressive. And since the government will be restrictive in all cases, the unions should be moderate. Why should the unions be moderate in all cases? Because they know the government is going to be restrictive no matter what. So they're choosing between their third best option and their fourth best option. They're going to choose their third best option. So we have this square here as a Nash equilibrium. So now we're done. Scharpf concludes this section in which he introduces these games by saying that the government has a dominant strategy. You now know what a dominant strategy is. Expansion in the Keynesian and deflation, or what he also calls restriction in the monetarist game. And they both have what I called a Nash equilibrium. In both cases, the unions are pursuing their interests, but the underlying power relations are entirely different. In the Keynesian game, in other words, when the government has Keynesian preferences, the unions are powerful because of the government's commitment to full employment, but they are entirely powerless when confronted with a monetarist strategy. One thing I would say is that it's not quite right to say a monetarist strategy. It's really monetarist preferences, right? Just like when the chicken game changed to the chicken game with the nutcase, that it was the change in preferences. It's the change in government preferences that drives this. The preferences drive the strategy. So slight pedantry there. But the point is that just changing the preferences changes the options for unions, changes what it makes sense for unions to do. How to relate that to the history of the 1970s and early 1980s and understanding the economics, that's something we'll talk about in lecture, in the seminars, but I hope what this presentation has done is given you enough game theory to understand it. And also, I would like to emphasize the terminology, Nash equilibrium, dominant strategy, etc., can be, payoff matrix is another one, right, can be intimidating, but we're really talking about something very straightforward. The other player is going to do this or that. What should I do? And that's all you got to do. Step through that. You can figure out how these games work. Okay, see you next week.